Hey guys, welcome to your math midterm day. I apologize again that I am unable to be there with you guys, but hopefully you all find this video pretty helpful as I am going to do my normal midterm review. And again, I'm going to be very detailed as I normally would if I was there right there in front of you. So I just want to discuss what you guys can expect to see as I do this review video. I am looking at the midterm that you guys will look at here in just a few minutes. So I'm going to walk you guys through section by section. As I mentioned last class, when I gave you guys your all's study guide, that if you didn't have any problem with the study guide, you really won't have any problem with the midterm, as the midterm is very similar to that study guide. So just walking you through what you guys can expect to see. We will start with what we started with our decimals. So again, remember on the very first quiz, the very first thing you guys saw was the rounding. So you all will see that on the midterm too. So for instance, if let's say we have, given a question where I have, say, 36, sorry, my pen's not working very well, I'll just use my finger, 36.825. If I said to take this number and round this to the nearest tenth, keep in mind that the tenth, you will always have one number after the decimal because that's your tenths place. The first place right after the decimal is your tenths place. So what happens when we're rounding? Remember, everything in front of that place value stays the same, so including the decimal as well. Everything after that, so in our case, the 2 and the 5, are being dropped off. Okay, because they're technically becoming zeros, and zeros at the trailing end of a decimal point can be dropped. That 8, one of two things is happening. It's either going to stay an 8 or become a 9, and that is based on the number right next to it. So again, we look to the number right next to it, which is a 2. Because 2 is a small number, that 8 will stay the same. If that number was higher, remember if it was 5 or higher, then we would take it up. But this would be your answer. 36.8 is this number rounded to the nearest tenth. If, say, we had that same number, so again, 36.825 once again, but I said to take this and round it to the hundredths place. Remember, now we're looking at two places after the decimal. So from that decimal point, so the decimal point that's right there between the 6 and the 8, remember, we're talking about from there. From there, one place would be the tenth, two places is the hundredth. But we apply the same exact rules. Remember, what happens is everything in front of it stays the same. So that includes our 8 in this case. Everything behind it is getting dropped again. So that 5 is going to get dropped. Now it's that 2. That's my hundredths place. But what's going to be in that hundredths place is dependent on the number next to it. It's either a 2 or it's going to become a 3. But once again, what we do is we look to the number next to it. And since that number is a big number, remember 5 and higher is considered large. So in this case, because it is 5, it is considered a large number. When the number is large, then we take it up. So we're going to take that 2 up to a 3. And so rounded to the nearest hundredth would be this. Remember, a way to remember that is rounded to the nearest tenths place. You're always going to have just one number written after that decimal point. Whereas if you're rounding it to the hundredths place, so hundredths, you're always going to have two numbers written after your decimal point. And that's all you guys will see on the midterm, is either rounding to the tenths or the hundredths, and that's how we would apply that. Next section that you guys saw on your all's practice study guide, we looked at the addition, subtraction, multiplication, and division of our decimals. So on your midterm, you will have one of each of those. You'll have one addition of decimals, one subtraction of decimals, one multiplication, and one division. I am making this as easy as possible. I want this to be something that you don't have to stress about. So on this section, you do not have to show me any work. So what that means is these 4 questions should be gimme questions. They should be guaranteed because you'll be able to use your calculator. So what I mean by that is when you get to this section, you see your first, where it just says what's going to say is add the following numbers. When I have something like this, if I have 9.38 plus 6.27, then you can just use your calculator on this. Don't feel like you have to actually take, 8 plus 7, carry the 1. You're welcome to do that, as I encourage you, and that's what we did the first day. But because nurses will always have access to calculators, I don't want you guys to have to stress on doing things like long division. So you're welcome to do that if you want to, but remember you have your calculator there to check your answer, but don't feel like you have to show me any work on this. You actually don't have to show me any work anywhere on your midterm. So hopefully that helps with that. That makes it a little bit easier. Those 4 questions, don't feel like you have to show me any work, so you can just use your calculator on those. The next section you guys are going to run into is your fractions extra credit section. I promised you guys that we would be finished with fractions. We are no longer going to have to add, subtract, multiply, and divide. I told you guys that those of you all who did feel pretty comfortable with fractions, that they are on here, they're on the midterm, but again, remember they are just extra credit. So for those of you guys that hate fractions, you guys can completely skip this section if you want to, and it will not count against you whatsoever. But for those that want to attempt the extra credit, just as a quick reminder, for addition and subtraction of fractions, we have to have common denominators. So just as a quick little refresher, so when I have, 1/6 plus, let's say, or let's make it 5/6 plus 3/4. When I'm adding these two fractions, what has to happen is I need a common denominator between 6 and 4. So with 6 and 4, remember, that means I need to look at all my multiples of 6 and all my multiples of 4, and we would find that the very first one they have in common is 12. So anytime I change that bottom number, remember I'm going to have to change the top number the exact same way. So because in that first fraction, in 5/6, when I changed 6 to 12, I changed 6 to 12 because I multiplied by 2. So because of that, I'm also going to have to do the same thing at the top, and 5 times 2 is 10. Sorry, I wrote that kind of weird, but it would give us 10. So that means that changes to 10/12. Now over here on the other fraction, I changed 4 to 12. So we had to think what I multiplied 4 by to get to 12, and it was 3. So therefore, I'll have to multiply this also by 3, and 3 times 3 is 9. So what that does when I add these two together, now I get 19/12, and then we want to reduce that. In proper fractions, we reduce by division. So 12 goes into 19 one time with a remainder of 7, and 12 stays our denominator. So that would be 1 7/12. So that's what we did with addition and subtraction. With subtraction, we would have had to do the same thing. If, let's say, this was a subtraction problem instead, so I'm just going to erase that plus sign and erase my answer over here. So just as a refresher for that, so if this was subtraction, then we would have done the same thing, found our common denominator to be 12, changed 5/6 to 10/12, changed 3/4 to 9/12. The only difference is I'm subtracting my numerators now, so I would get 1/12. And don't forget, don't be thrown off when you have a number in front of those whole numbers. If this instead was, same exact problem, let's say instead of 5/6, let's say it was 7 5/6, let's say minus 2 3/4. Same thing has to happen. 5/6 would become 10/12. I'm just doing this quickly because this is exactly what we did, in this right here in this section. So 5/6 would become 10/12. 3/4 would become 9/12. We know that when we subtracted those two, we got 1/12, as we did just a second ago. The only difference between these two problems, so I'm going to separate them, show that they're two problems. The only difference is that now I have to go back and get that that 7 and that 2. So 7 minus 2 I know is 5, so my total answer here would just be 5 1/12. So don't be thrown off if you have mixed numbers. The great thing about addition and subtraction using mixed numbers, you can separate the whole numbers from the fractions. The difference here between this and now then our multiplication and division, let me get all this madness out of the way here. Okay, there we go. If we had 5/6 times 3/4, then all we do with multiplication, we do not need common denominators. All we're going to do is multiply straight across. 5 times 3, 6 times 4, 5 times 3 is 15, 6 times 4 is 24. Just don't forget to reduce because 15 and 24 are both multiples of 3. I can reduce these both by 3, and when I do so, 15 divided by 3 is 5, 24 divided by 3 is 8. And yes, for those of you guys that are reducing before you multiply, you guys could have reduced at the 3 and the 6. So very well, could have worked if you wanted to. Let me see, going back to that one. So that again was 5 over 6 and 3 over 4. So multiplication, that's what we had to do. We just went straight across and then reduce. The only thing that we had to pay attention to in multiplication, actually let me do two different numbers. What we have to pay attention to in multiplication is if it's not in that numerator-denominator form, we couldn't just multiply straight across, like we did on that one. Only other numbers that you would find that are not in numerator-denominator form would be if I had, say, for instance, a whole number or a mixed number, so like 3.5. So where I have a whole number and a fraction in that number. Neither one of these are in that numerator-denominator form, so we have to put it in that form. Anytime we have a whole number, I just simply take it and put it over 1. Now I have a numerator and a denominator for that number. With mixed numbers like we have there, 3.5, I make that improper. And we do that again by taking 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7, over 2. Denominator stays the same. So all we do now is just like we did on the last problem, I'm just going to multiply straight across. So 9 times 7, 1 times 2. I don't want to do too much because I don't want to give away too much because these are extra credit, but that's how we would approach that. And what's great about division, if this was a division problem, so we would do the same thing first, make that 9 over 1, make that 7 over 2 because it needs to be in numerator-denominator form, but remember in division, we keep change flip. So that means we would change this to, or we keep 9 over 1, change or division into multiplication, and we flip 7 over 2 to 2 over 7. And then it's multiplication, so we go straight across. So that was the multiplication. That was the division. So remember that in multiplication and division, your first step is to put it into numerator-denominator form. Okay, so I know in class, and so that's extra credit. So again, I didn't want to do too much with that. As again, don't forget, fractions are extra credit, so they don't count against you if you don't do it. The next section that you'll run into is really, this is kind of out of order. I know we did proportions next in class, but it looks like this is I just kind of threw this in, but you guys will actually run into your combined applications next. That was the very last thing we did in class last week. That was the fraction to decimal to ratio to percent. So just taking a look at a couple of those. So again, this is the last thing we did, so hopefully this is all still fresh in our head. But we've got our fraction, decimal, ratio, and then percent. So remember, what's going to happen is I'm going to give you one of these 4, and I want you to give me the other 3. So I'm actually going to do a couple examples that are very similar to what I'm looking at on your all's midterm right now. So for instance, the first one, I'm going to start with a decimal. If I start with a decimal that, say, looks like, this is very, very close to what you guys are going to see, practically giving you guys questions here. But anyway, if I start with this decimal, a couple things can happen with this decimal. One, I know how to convert a decimal to a percent. It's just a matter of moving that decimal point to the right twice. Remember, decimal to percent, because percents are always out of 100, we're moving that decimal by 100. So meaning one movement would be 10, 2 movements would be 100. So this would become 6%. So always, 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 decimal to percent is 2 places to the right. And then vice versa. Had I started with that 6 and that percentage, then I would have moved the decimal 2 places to the left to turn that into the decimal, 0.06. So anyway, so that's what we get with that percentage. I could have also taken that decimal and converted it to a fraction. You can actually get your fraction from 2 places on what we have on the screen right now. Because we talk so much about how percentages are always out of 100, you very well could look at this, and since we have that percent over here now as 6%, you could look at that and say, oh, well, 6% means that I have 6 over 100. Or another way to think about it, just like we did a second ago, if you remember the decimal to fraction, decimal to fraction, we would take that decimal point and move it as far right as we can to turn it into a whole number. In this case, it just so happens to be twice to get it to the end. But what that does when we move it as many times to get it to the end, that turns it into a whole number. That turns it into the whole number 6. And remember that decimal movement that we just did is actually going to determine what our denominator is. And we talked last week, remember your denominator will always be either 10, 100, 1000. Starting off, it'll be one of those three numbers. I won't go any bigger than that. But that's based on that decimal movement because every movement is based on tens. So just to remind you guys what I had mentioned last week, remember that the number of movements will match the number of zeros in that denominator. So 2 movements means 2 zeros, and that's where 6 over 100 came from. So you can get that from either place. Either remember percents are always out of 100, or 0.06 is the same thing as 600ths. But do not forget that we always want to reduce our fractions. So reduce our fractions. 6 and 100 can both be divided by the same thing. They're both actually multiples of 2. So dividing those both by 2, whoops, I didn't mean to move that. Dividing that both by 2, that would give us the fraction 3 over 50. And so there's our fraction. And because that's our fraction, our ratio would then be 3 to 50. Always remember to reduce. So that's what we get on that one. Okay, so let's take a look at, oops, of course I deleted everything. All right, so taking a look at maybe another one. So I have to rewrite my chart up here real quickly. Fraction, decimal, ratio, percent. Okay. Okay, let's say I give you guys the fraction, say, 3/8. 3/8. So a couple things can be done with a fraction. I know if I just divide that fraction, that'll give me a decimal. Or fractions and ratios are pretty much the same thing, so I can get it from there. Let's just take it to the decimal first. So remember, fraction to decimal is just numerator divided by denominator. So if I just took 3 divided by 8 in my calculator, it's going to give me 0.375. So there's my decimal. 0.375. From there, I can go ahead and convert that. I'm going to go ahead and just go in order. My ratio, remember, comes from that fraction. Whatever my fraction is, I can just rewrite that in ratio form. So 3/8 is the same thing as 3 to 8. And then our percent is going to come from that decimal. So just like we did on the last one, don't forget though, decimal to percent is always just 2 places to the right because we're always moving by 100. So we're always just moving twice. So 0.375 as a percentage would be 37.5%. Okay. And then let's see. So let me just erase these. So let's look at another one. So I know you guys had one on your all's practice, and this is one that I always get questions about. But you all had one on your practice worksheet where we started with a decimal that had a number in front of it. So I think we had something like this, 5.45, and you all have one very similar to that on your all's midterm. So I had mentioned to you all last class that remember, anytime we have a number in front of our decimal, that will also be the number in front of our fraction, and vice versa too. If we started with a fraction that had a number in front of it, like a mixed fraction, that would be the same number in front of my decimal. So it's the same going both directions. So what we can do is, since I know there is a 5 in front of that 0.45, that I'm going to go ahead and just write down as that's the number that's going to be in front of my fraction. What that's going to turn into is going to be a mixed number. It's going to be 5 and some fraction. So the rest of that is going to come from that 0.45. So imagining that now I'm just looking at, as if it's 0.45. So I'm going to erase that. Just looking at 0.45. So imagining it's 0.5. Whatever I turn into a fraction is going to just go right behind that 5 as the whole number that I have written there. So remember what happens when we're turning a decimal into a fraction. I move my decimal point as many times as I can to get it to the end, and that will turn it into 45. The number of movements means number of zeros, so that's going to be 45 over 100. Because again, 2 movements, 2 zeros. But 45 over 100, I can reduce this further. I'm going to reduce this because I can divide those both by 5. Anything that ends in 5 and 0 is a multiple of 5, so I can divide those both by 5. And so what happens here, 45 divided by 5 is 9, and 100 divided by 5 is 20. And I can't go any further than 9/20ths, so that means that's going to be the fraction that goes right behind the 5 in that fraction category there. So my fraction is 5 and 9/20. So same thing. So again, if this was 0.45, my fraction would just be 9/20 on its own, because that's 0.45. But at any time I have a number in front of that decimal, that's going to be the number in front of my fraction. So if this was 8.45, then my fraction would have been 8 and 9/20. If this was 14.45, then my fraction would have been 14 and 9/20. So it's just a matter of, again, anytime we have a number in front of either the fraction or the decimal, it'll be the number in front of the other one. Always. Every single time. We can get our ratio now that I have my fraction. The difference is with a ratio, so I usually draw that in yellow, the ratio is always a comparison of two numbers separated by a colon. So I'm going to have a number here and a number here. So if this fraction was just 9/20 by itself, then my ratio would be 9/20. In my previous example, my fraction was 3/8, so therefore my ratio was 3/8. So the problem is this time I have three numbers. So what we're going to have to do is we're going to have a little intermediate step here. Anytime I have a mixed number, what I'm going to have to do is make it improper first, and then that's where our ratio will come from. So again, making a mixed number an improper fraction. We take the whole number, so in this case 5, times the denominator, then plus the numerator. So I'm going to take 5 times 20, which is 100, plus 9, which is 109. So I'm going to get 109. And then the denominator just stays the same, so 20. So as an improper fraction, this would be 109 over 20, but that's where that ratio is going to come from. My ratio is then 109 to 20. So anytime you have a mixed number, simply just make it an improper fraction first, and that's where that ratio will come from. All right, and lastly, that percentage, the percent is going to come from the decimal. So remember, every single time you've got to move your decimal point just 2 places to the right, and that will give you that percent. So just like we've done a couple before, since I have a since I have a large decimal, that means it's going to be an even larger percentage. 2 places to the right would make that 545% in that case. So that's what we get on that one. So I hope that helps with those examples. So that's what you guys will see next. Next, you guys are going to run into the proportion section. So let me get all that out of the way here. So with the proportions, you're going to start with some that are set up for you. So meaning if I had, like 3 is to x as 6 is to 10. So remember, proportions are kind of like analogies, that this says 3 is to something as 6 is to 10. This is the right side of this proportion is my known relationship, and this is my unknown relationship. Remember, you could do either or. You could either leave it in this ratio form, or remember that 3 over x and 6 over 10 is the same thing, if you'd rather see them in fraction form. But what we're going to do, remember our shortcut for these is to find where x is in our proportion. So there's x in the bottom left there, which means I'm going to multiply the opposite side first. So I'm going to multiply 3 times 10. If we're using at the top there, if you're using the ratio method, since x is one of our inside numbers, then you would multiply your outside numbers first. So 3 times 10 in both cases, no matter which one you're using. It's 3 times 10, which we know is 30. And then our next step is to take that answer and just divide by the last number. So we get 30, and then now I'm just going to divide by that 6. And 30 divided by 6, so I'll write that out. 30 divided by 6 is 5. So that means x is equal to 5 in this case. So it's just solving for that unknown every single time, and we've done this many times because even last week in our percent chapter we worked with these proportions. It's always just cross multiply and divide. Cross multiply and divide. So no matter where x is, it's always the same setup. Cross multiply and divide. So you'll run into, on the next section, you'll run into that same type of scenario where we're filling out the percents. And so what it even says in that section, it even reminds you that, remember, when we did percents last week, that we have this formula to follow. And that is written on the midterm for you guys so that you have this. That percent over 100 is equal to is over of. So if I asked you guys, what is 15% of 80? Then again, you can pick this apart. We know that the percent always goes here. So in our question, that means 15 will go over top of 100. We know that is always goes on top of. In this question, I'm being asked for the is. So it says, what is? So in that case, that's my x. X goes into that is position. And then it even told me of 80. So 80 is going to be what goes in that of position there. And so just like all proportions, we find where x is. Since x is up here in the upper right, I'm going to multiply 15 times 80 first. 15 times 80 is 1,200. And then take that and divide by 100, that last number there. So 1,200 divided by 100, x is equal to 12. So we get 12 on that case, in that case. So this works, again, no matter what we're looking for, we would use that formula. If I said, let's say 32 is what percent of 40? So in this case, I'm asking for the percent. So that means x is going to be what goes over top of 100, and the other side would be 32 over 40, since it says 32 is of 40. It's telling me what position those should go in, and so again, to solve it, we would cross multiply 32 times 100 divided by 40. Okay, so remember that, and that formula is there for you to remember those questions. So I know then last week we also applied those a little bit further, especially with discounts or, what have you. If I had, say, if I said the full price of an item is $65. Oops, that's a dollar sign. Is $65, but I said today it's 30% off. I want to know what I'm going to end up paying for this item. So that was kind of a popular one, that we're looking to apply these a little bit further. So what we have to figure out first, well, and what is 30% then in terms of money? I need to know what I'm going to end up paying for this item. So if I get to take 30% off, what is that in terms of dollars and cents? So what we had to do is we had to ask ourselves first, well, what is 30% of 65? So in doing so, and again, so this is the question we're asking ourselves, what is 30% of 65? So just another way to kind of look at that to see what we're, or how we're going to set that up. We have, there's our is, our percent, and our of. We're looking for 30%, that's our is, and our of. So there's 30% of 65. So when we do so, when we take 30 times 65, we get 1950. And dividing that by 100, that would mean that it's 19.5, or in terms of dollars and cents, that's $19.50. But again, it's 30% off, which in terms of money, 30% was $19.50. So that means we get to take $19.50 off of that original price. So we would take $65 minus $19.50, which means I'm going to end up paying, the answer here would be what I end up paying for this item, which is $45.50. So that's what I'm looking for here. So it's just applying that. And remember, we went over last week that you're always going to be looking for your is, and that's what either gets added or subtracted based on what the amount, what the question is asking us. In some cases, if I said that, a patient needs to gain 30% of their weight, maybe a patient that's, as we talked about last week, maybe experiencing anorexia or something, they need to gain more weight. So we would take that 30%, but then it ends up being added to the weight. So there's a couple questions on there that then have you then apply that a little bit further. Let's see, so there's the percents, and then next you guys are, the last thing you guys are going to run into are those conversions. So the last thing you all will see are our conversions. So I mentioned to you guys that you had to memorize the conversions by the midterm. So you guys unfortunately will not be able to use your all's equivalent sheet today. And I mentioned that to you guys in the email I sent to you all yesterday as well. So hopefully you guys remember that. But the equivalents are just in our head now. But you all are welcome to, as soon as the test gets handed to you, feel free to then just spill it onto your scrap paper or something, but make sure the tests have all been handed out first. As soon as the tests are all handed out, you're welcome to jot down all those equivalents and get them out of your memory. But when we have those, so what happens on these, remember there were one of two ways that we could convert these. If I give you guys, say, let's say I have, I don't know, let's say 7 cups, and I want to know what that is in ounces. There were a couple ways that we could convert this. So there was remember we talked about larger to smaller means that we're going to multiply, and smaller to larger means that we're going to divide. Or there was the proportion method. So looking at this question, what I mean by the larger to smaller, smaller to larger, if I think about that known for my cups and ounces, if you guys remember, 1 cup is 8 ounces. And so remember in this case, what that means, based on that known, whatever is your 1 in your equivalents, so in this case our cups, that's our larger unit. And again, I always use the kind of situational thinking, well, ounces must be pretty small then if 8 of them fit into that 1 cup. So in this scenario, our relationship between cups and ounces, cups are bigger than ounces. So since I'm going from the larger unit of cups and I'm trying to convert that to the smaller unit of ounces, this is a larger to smaller conversion. And anytime you're going larger to smaller, for those of you guys doing that, we multiply. So it would simply just be 7 times 8. It's always the question the number from the question times the number from the known. So it would be, 8 times 7 is 56. For those of you that don't want to think about larger to smaller and smaller to larger, then it's simply just a matter of knowing that this is your unknown, this is your known. We just need to set them equal to one another as fractions. So if it helps, I know I'm just kind of in a habit of writing that unknown down first, 7 cups and X amount of ounces. So both of these parts of the unknown have to be the same fraction. So 7 cups and X ounces, you notice they are on one side of my proportion. The other side is going to be the 1 cup and 8 ounces. But remember, the big thing for proportions is our knowns and our unknowns. When we're setting them equal to one another, the units have to match up. So from this, the known here, the 1 cup and the 8 ounces, I'm going to put my 1 cup on the top to match from the fact that there's cups on top on the other side. And then I'm going to put my 8 ounces on the bottom to match up with the ounces over there on the other side. So I followed those two rules we've talked about. Unknowns on one side, known is on the other. Now I've got my units matched up too, so I've set everything up correctly. I just need to cross multiply and divide. So now cross multiply that side since X is here. That's why I took 7 times 8, which we know is 56, divided by 1 is still 56. So no matter how you're doing that, if you're thinking larger to smaller, then we would have just multiplied. Or again, if you'd rather see that set up in a proportion, that's how we did that. Taking a look at another one real quickly here, if I said a patient is, say, 160 pounds, and I want to know what that is in kilograms, then again, thinking of our known for pounds and kilograms, 1 kilogram is equal to 2.2 pounds. So therefore, this is a smaller to larger conversion. So we would simply just take 160 divided by 2.2, because we always divide when we're going from smaller to larger. So our answer here should be 72.7. So for those of us that are using the proportion method though, same setup. Take your unknown from your question. So there's our unknown, 160 pounds over X amount of kilograms. And then I'm going to set that equal to this guy right here, my known. But again, pay attention to those units. What's going to happen is one's going to go on the top, either this 1 kilogram or the 2.2 pounds. But because pounds are on top of that unknown side, I'm going to make sure the 2.2 pounds goes on top. So 2.2 pounds and my 1 kilogram on the bottom. Now my units match up. So when I go to solve this, I'm going to cross multiply. 1 times 60 is 160. Then 160 divided by 2.2 would still give me 72.7. And how you round that off, if you did that in your calculator just now, it's 72.727272 repeating. The only place that I am particular on the midterm today is the rounding section at the very beginning. Everywhere else, if you get some kind of random decimal like that, round it off how you choose. If somebody on that said 72.72 or 0.73, or if somebody even, if you rounded it up to the nearest whole number, then that would be fine too. If you rounded it to just 73 kilograms, that would have been fine as well. It just means that you did the right thing, you just rounded it to a different place value. And that is totally fine. So that's the last thing that you guys will run into on today's midterm. So I hope that helped. If you guys have questions, feel free to ask Lily, and then Lily actually has class at 9 and she is going to leave and Josh is going to relieve her. But if you have questions that they can't answer, then they can reach me by my phone. I can try to be available by phone and I will try to answer as best as I can. So if you have any questions, please feel free to ask. I hope that helps. Best of luck today. I know you guys are going to do great.